My name is José Luis Luna Sanchez. I am going to present you the research that we are developing at the Laboratory of Nanophotonics and Photothermal Techniques in the UPITA IPN. Is a particle of semiconductor that is in nanometric dimensions. It is said that a quantum dot has confinement in its 3 dimensions. Since its discovery, quantum dots were synthesized from transition and heavy metals, making them usable only on technological applications due to the risk to health and to the environment. Carbon quantum dots were discovered and envisaged as fresh material to be used on biological applications. They are assumed to possess reduced toxicity and to be environmentally friendly, but there is still too much research to do about its activity in vitro and in vivo. In this research, carbon quantum dots were prepared and are being characterized physicochemically as a first step to deeper research on bio-applications. We used a dextroglucose solution as origin of the quantum dots. We energized it with the aid of a domestic microwave. After the reactions were stopped, we recovered the products into an aqueous solution and sonicated it for 30 minutes. Then centrifugate them to separate clusters, and we are today characterizing them. Later, carbon quantum dots are going to be functionalized to be used as cellular biomarkers. In the left plot, we monitored the reaction by following the absorbance developed by the reaction products. In the right graph, the maximum absorbance is plotted. We can observe that the production of quantum dots follows an experimental behavior, and as observed experimentally, it is not recommended to use the microwave for periods longer than 10 minutes. In the bottom of the slide, we can see GIF images of the synthesized carbon quantum dots. The test tubes were illuminated with an UV lamp into the dark. The UV radiation is absorbed and delivered with a different wavelength. We evaluated how the thermal diffusivity changed for each experiment, and we found that this property increased from values near to that of the water up to 5 times higher. In this slide, we can observe how the experiment is performed. A red laser is used as probe beam. It passes through the sample and is collected by a sensor. A green laser is used as pumping beam to energize the sample. The green laser is controlled with a shutter. Then, when the pumping laser passes through the sample, the temperature increases, the density changes, and the red laser changes its path. Such change in trajectory in milliseconds is detected by a sensor and registered as a decrease in luminous intensity. The experimental data are fitted with the equation of Fresnel theory resolved in terms of time. Then, the black circles are the signal detected by the sensor. It starts with a high luminosity and then it falls and stabilizes. The first plot is the calibration of our experimental setup. We calibrated it by measuring the water diffusivity, and the last plot is the resume. We can observe how the thermal diffusivity starts with a value near to that of water. Water is marked at the left of the plot with a blue star. The thermal diffusivity rises up to values near to 50 square centimeters by a second. Conclusions. Microwave-aided synthesis is a fast, green, and safe method to obtain carbon quantum dots. The reaction runs with exponential increase in speed, so it is recommended to select reaction times shorter than 10 minutes and combine it with low power. The diffusivity of the synthesized carbon quantum dot dispersions is increased linearly with respect to reaction time. References. Thank you for your attention.